And so we come to the fun and games portion of our schedule. This was originally going to be presented by Steve O'Connor. Unfortunately, he's had to deal with certain emergencies at his end, including, I understand, running away from bushfires or dealing with the fallout. And so it's not been possible for him to find an internet connection to live stream his presentation. However, I hope that I can fill in a couple of the gaps, and by kind permission of the GopherCon Australia group, it's going to be possible to share with you some video footage that he recorded a couple of weeks ago at the Australian GopherConf. So with that, I thought it would be really useful just to step in and look at the examples repository, because this has a lot of different functionality embedded in small and fun little applications that can be really helpful if you're looking to understand some of the more complicated functionality. So let me bring up the examples application. Now, this can be downloaded and installed locally if you would like to play around with it on your own computer. Go get github.com/fyne-io/examples. We'll download, compile and install this application on your computer. Of course, you could get the code yourself and run Fyne install if you would like it to be in your application launcher like that. But otherwise, this will install it to your command line and you can use the examples command to load it. So I thought it would be helpful just to look at some of these. As you can see, it's grouped into two sections. We have canvas applications on the left and widget applications on the right. You may be able to guess the difference. Yes, on the left, these are applications that use only the built-in canvas primitives, so that is lines, circles, text, rectangles and images and gradients as well. But they are going to look exactly the same irrespective of theme, because they are determining how to draw in their code directly. And on the right hand side we have some widget examples. These are built with the standard widgets for the most part and are going to change their look and feel based on the theme settings. So here is the clock application. As you can see, it is using the circle and line, and it is also going to scale appropriately for our window size. Those elements are placed by a layout routine, which can be explored if you look at the clock example code. But otherwise, it is a background Go routine, making sure that the UI updates every second. The hand does use the primary color from the theme just to blend in. In fact, the application itself is designed to look like it is built with widgets, and in fact that's possible for any code that you want to build, but using custom colors you can also use the theme colors and adapt when a theme changes if you wish. I also would like to show the solitaire application. This is an interesting application because it showed us just how difficult it is to really efficiently render lots of vector graphics to a screen. When you start working on large desktop screens, there is a lot of pixels to be filling in. And so we spent some time looking at how to optimize the output, the caching and the rendering so that such an interface would always feel performant. We can apply transparency, move objects around, all just completely smoothly as you would expect. And these, being vector graphics, will adapt to whatever screen resolution it is that you're drawing at. Okay, so let's have a look at the widget-based applications. The calculator here, it is pretty straightforward, does exactly what you would expect for a calculator, and doesn't need any code to handle how these buttons should look. It is simply packing standard widgets into a container. And so if we bring back our settings application here, you can see that changing the theme is going to change the calculator, and you might notice the clock has updated as well as we put some code in to handle that. And then similarly we could choose to scale the applications, and it's all going to update as you would expect. The interesting additional element for the calculator is that it shows how we can take keyboard input without having an input field. So your application can listen for certain input. So here I am typing and hitting enter. And so you could see it has simulated the button presses. And in fact, if you look at the code for the calculator application, it also contains unit tests that demonstrate that if the certain buttons were pressed, then the right output is evaluated. And also I will show the text editor. This for a while was our standard code for getting started slides. It's everything that you would need to start a basic application there. It has a toolbar, you can reset the content, and these values at the bottom are updating each time the content of the entry changes. This is quite interesting both for the layout, and also it is introducing background changes to content, and you can simply update these on a callback, and then the application will refresh to show the result. This application is using the border layout, which we skimmed over when looking at the demo application, and it is saying that the toolbar should always be at the top, the status bar should always be at the bottom, and our entry widget should fill the middle. Now, that is our examples application. I didn't cover all of the applications in there because Steve did a fantastic job of showing how some of these can work, and so with the permission of the kind people at FyneConf Australia, I'd like to play you an excerpt from his video.
So let's say we have a frame buffer device with, say, 64 pixels in a square, and we want to animate that using Conway's Game of Life rules. That's one of the example applications. The code behind that now, we'll look at the animation loop. So we have here a simple go routine, fires off a ticker. We're pulling from the ticker channel 6 times a second, and then down the bottom here, generate the next iteration of the screen, and then widget.refresh. That's very simple code. It's using standard Go tooling. It's using all the good bits like Go routines and channels. And you'll notice here we're actually painting from inside of a Go routine. And if you've ever done any graphics programming, you'll quickly realise that they have this affinity to the main thread. So trying to do a separate thread over here that's pointing to the screen is problematic. That's all covered within the Fyne toolkit. We've taken care of all of the multi-threading problems that you may have with other toolkits. A little bit of code there. That just shows what we're doing internally to take the current data set on the board and generate the next frame in the game of life program. It's just looping through XY coordinates. If there are 2 or 3 neighbour cells that are populated, then that cell stays alive. Otherwise it clears it, and then we just set that into the buffer. Quickly jump to the next one. This is a custom draw routine that we're attaching to a custom widget. So you can write one of these that will return a standard go image.image, and then you can put whatever functions you like in there to get data out of the current state you've got, use standard go functions to generate a new image and return that. Fyne will then take the image that you've returned and worry about blitting that onto the screen in the correct main thread and everything else. Okay, quick demo. Over here we have the examples application that comes bundled with Fyne. There's a number of different little toys and tools there with all the code behind that you can dig into and see examples for how to do various things. We'll have a look at life. So here's our little program that we just looked at a second ago. That's doing an animation loop 6 times a second, taking that frame buffer information and blasting it out onto the screen. And again, there's one function there that is needed for your custom widget, which creates a standard Go image structure and returns that. We'll have a look at one other one while we're in here. This demonstrates a different way of doing custom widgets. This is your standard Mandelbrot set. So with this custom widget here, this takes a different type of function that takes an X and Y coordinate and returns a colour that is represented at that pixel. So if you create a custom widget using that fractal method there, what Fyne will do is every time a repaint is required, it'll iterate through every pixel within the display, calling your custom function to get the colour that needs to go in that image. So for example, if I scale that one up, if I just drag the window, that'll cause a repaint on that window. So when I release the button here, Fyne will then go off, ask your program what the colour value should be at every single X and Y, and then it will just repaint. And it's quite quick. Got some keys here so we can zoom in and have a look around. Performance is pretty good considering how much work is going on there and how simple the code is in your custom widget to achieve that. Make sense? Okay, let's quit out of this. Quit. So a small recap on that. Basically using all of the good bits of Go, all of the hard bits are hidden away by the toolkit and you can get in there and start hacking away very, very quickly. Okay. Gopher's come up with a tricky one here. With that particular life program, we did spend a couple of weeks on that one online, working out a lot of memory leaks, buffer overflows, and there was some very, very tricky data race conditions happening in there. So when we got to the end of that little project and optimised that so that it was working very nicely with little code, we were saying on a Friday night, wouldn't it be cool if we could just plug a basic interpreter into that and turn it into a retro gaming console? Because it's the same concept where you have a simple frame buffer of 60 by 60 pixels, and you just want to be able to address those from code. So on Friday night, we had a look around and sure enough found that someone had written a basic interpreter in Go. So then finished off my beer and got coding and by the end of the weekend, we each came up with a very separate implementation using those tools. The approach I took was to write a virtual machine emulator in Go. That probably sounds a little bit overwhelming, but it was actually very simple. It's basically just mapping a frame buffer, creating an animation loop, and then loading in the basic interpreter to run some instructions. Over on the right-hand side here, there's an example basic program that will animate a bouncing ball bouncing around the screen and off the walls and everything. In order to hook that into the virtual machine emulator that I wrote, I had to extend the basic interpreter to enable the program to read and write into the frame buffer, give it a way of getting input via a key interrupt, and then generating a vertical sync interrupt here to tell the basic program that the animation cycle is complete and it can go and paint a new screen. That's a lot of words, but over on the right, there's the basic program to do that. And this is just using off-the-shelf stuff that we found on a weekend, so. Okay, let's see if we can run that. Gopher wants to have a play. So there's our little virtual machine running the basic program, doing a physics engine to animate a ball floating around. And there wasn't really that much code on there to do that. All of the code is again linked on the on GitHub. Thank you, that's really cool. And if I move the keys around, I can interact with that ball to push a vector on there and make it bounce in different ways. And if I hit the escape button, that powers it off. We've even got static emulation on there, and up it comes again. So that was a very small program, and that was something we knocked out on the weekend. It's good fun. Oh, we have a friend. He wants a game for 2 players. Okay then, let's try it again. Here we go, same concept. We've got the same emulator. We've just written a little basic program that will emulate the good old Pong game, using VI keys to manipulate the paddles, of course, as you do. So there we go. I can never win at this thing. So that entire thing took me probably up to Saturday night. While that was happening, Andy in the UK, he lives in Scotland, went off and did something very similar, using the same tools, but to come up with, whoops, something quite different. He wrote a BBC Micro emulator that you can program yourself. And everyone's first basic program, if you can remember this one. Oh no. Live coding, love it. Hello, oh that'll do. Ta-da! So yeah, good fun. So what I'm trying to get at here is that Go is a real compiler, so you can write real programs with it very quickly. There's no messing around with hairballs of JavaScript. There's no messing around with trying to get the right link libraries in C to not completely take up your entire weekend. And more importantly, Go is such a good language that you can hop on the internet, find really cool and weird things that are written in Go, and after a short read and a beer, you can understand what they're trying to do and how to get in there and change it. And maybe even hack what they've done to change it around and interface it with your own silly ideas. And it's all easy and it's all good and it's all very robust. You should do it.
Thanks, Steve. That was really cool. Now, I'm going to continue the fun and games with another example. A little bit of 8-bit fun. Now, if anybody has been watching the cool projects in the Go community, they might have seen a Game Boy emulator before by HFO4. He did a really fantastic job of writing the entire emulator, decoding the ROMs, and running in a bitmapped window. But we thought actually maybe we could take it one step further and bring the Game Boy into something that looked more like a Game Boy. So to do this, we wrote a simple application that loads the bitmap content, applies an image filter over the top, and then put it inside a layout which draws a border around it. Pretty straightforward, but it really adds a nice little touch. And so, like the examples that Steve was showing earlier, this is bitmapped pixels frame buffer inside a scalable application context. So if I just switch out of full screen here and bring a demo in, I'll show you what that means. Let's start with everybody's favorite, a little bit of Tetris. Let's see if I can get a line. Okay, that might be my worst beginning to a game of Tetris yet, but we can take that up to full screen and you can see the vector graphic portions are looking really great and the application is still continuing at a good speed. And this game is really not going well. Surely live coding is preferable to live gaming. Before I do any worse on that, I'm just going to quit that demo. And instead, for a little bit more animation, if anybody likes a good title sequence, this has to be my favorite. The Legend of Zelda: Link's Awakening? Oh yes. In pretty much full screen. And that is probably enough of that. I'll get carried away and I'm sure there's some copyright issues there as well. So that was a look at the, hey, this is really fun side of things. And it absolutely is. I encourage you to go and check it out. What we see on the right hand side, I should also add, is how this could look when you load it on a mobile device. Now, this is a screenshot of the work in progress. It hasn't been pushed to the main repository, but based on what I was saying earlier, you can imagine that this is happening when the application realizes it's running on a device with no keyboard and it's in the portrait mode. So what it's doing is it's laying out buttons, 8 of them, that are going to receive touch input like any other button, and it will use those to generate the codes that the keyboard would have been doing for the desktop application version that we saw before. And hopefully this will be available shortly after the 1.2 release, and we'll be able to show that running on mobile devices very soon as well. Now, that is all very fun, and thanks again, Steve, for running through that exciting part of frame buffer manipulation. And I mean, the BBC emulators just were hours of fun. I'm so excited that you found that project. But what about work? This is not a toolkit that was purely put together for entertainment. We all want to enjoy what we're doing, but sometimes that needs to be work. And so I wanted to talk a little bit about, could you use the Fyne toolkit in your work day to day for the projects that you have to deliver, that your business depends upon? And well, I mean, the answer to that is absolutely yes, people are doing that. I was looking to have some speakers come on and talk about the applications that they're developing. Unfortunately, naturally, they're closed, not open source applications have largely been in a current development stage. That means they're not available to talk about, or in fact, they are developing really solid back-end applications that we're never going to be able to see. However, we'll work something out for the next conference, I'm sure. So back to Fyne. How can you rely on this in your day-to-day? Well, this project has been around now over 18 months. It's been growing steadily and has a really solid basis for any of your application development. Our 1.0 release was back in March this year. That represented a significant amount of development, but still showed us there was a very long way to go. There was a very interesting discussion on Hacker News where they suggested that 1.0 might be a bit of a risky approach, and they suspected that APIs would be broken and that applications wouldn't continue to compile. Well, thankfully we're able to say that they were wrong about that, and that our APIs have remained compatible throughout. 1.2 is the first release that introduces some things close to needing a little bit of code altering, but really that is only going to apply to custom widgets that have been created before, and we did discuss this with people that unfortunately to do this right would require a little bit of change. That said, of course, any applications that you build are going to continue to work no matter what, because like any Go applications, these are compiled binaries that work independently of the toolkit that they were built with initially. Since 1.0, we have had another 4 releases. 1.01 helped to address some challenges that were raised after the 1.0 release as we rolled it out for the first time to public consumption. And then 1.1 added some really cool functionality, some new widgets. It's when we saw shadows and some hover effects being added, and it became something that was a little bit more alive and felt more responsive than the first release, which was perhaps a little static in its presentation. And since then, we have had 1.1.1 and 1.1.2, which have each had added some bug fixes, some optimizations, and some small pieces of functionality contributed from people around the world. Those releases have been spread relatively evenly across that period of time, so there's always a new release somewhere soon. If a bug fix is absolutely critical, we can pull that forward, and if we're collecting improvements or functionality that is less critical to the running of existing applications, we might push that out and create a bigger release, such as the 1.2 that we're talking about today. Talking about the contributions coming in, GitHub reports that we now have 30 contributors, and that's on the master branch, so I'm quite certain this is many more now. That we've had great help from people coming in for this new release, including as well as a lot of developers, which you can find named in the commit log or the contributors list. Also, we've had help on graphic design from ASCII Face Man and Storm, who really helped put together the animation and the logo that you've seen so far today. But also we've had testers and people contributing documentation literally from all around the world, which is really fantastic. And if your business isn't ready to rely on a purely open source project, then we're also really happy to be able to offer commercial support for companies that need a piece of paper or a contract. And you can find more information on the support page on our website, which is there, fyne.io/support.html. That's pretty much why we think this works in a business context. And whilst I can't really hand over to people who've been using it in their businesses, there are some projects that I thought it might be nice to share to illustrate how that's already helping people. So if you're in networking, OpenSnitch might be something that you're used to. And this project here, again by Luca, one of our core contributors, put together an interface quite some time ago just to show how easy it was to bring an otherwise less usable application together quickly on the Fyne toolkit. You can get the application from the URL at the top there. Using the go get command will install it to your command line, or you could download it and build and then install using the Fyne install application command I showed earlier. So that's something that just shows that you can put any utility that is a bit of a pain to use into a nice graphical interface. But what about something that is more intensely graphical? Well, it was an idea that was suggested to me by a doctor that imaging applications are either expensive or very slow or don't support the applications, the devices that doctors carry with them day to day. It's sitting on a Windows desktop or a Mac desktop in their office somewhere. Could we bring that to mobile devices, to portable devices, and could we do it using open source technologies and therefore offering it at a very good cost? Yes, as you can see from the image here. The picture is of a simple Fyne application that was put together one day. Literally, it took less than a day. The images are decoded from the DICOM standard. Thankfully, as Steve was saying earlier, there are lots of great libraries out there, and somebody had written a library to decode the file format, which was really great. We loaded an application, the buttons, a simple layout defined down the left-hand side, and the image content was given most of the screen real estate. As you could see, there are we're currently showing, frame 83 of 128, and so you're able to tap up and down through different slices of this medical image. This is all happening efficiently and in real time on a Raspberry Pi, which is plugged into the side just off the shot, and this screen is a touchscreen device that was purchased very cheaply but works very well indeed for such an application. And so we were able to show how a portable or platform agnostic viewer application could be put together on hardware that cost less than $100, and the software was basically free. That is available through the GitHub account of one of our commercial partners, although it hasn't been published on their account yet. The link will come soon after this conference is finished up. And so that is a couple of applications that we have seen out in the wild that maybe we've been working on. But how would somebody know where these applications are, or is there a showcase or something like that? Well, it's fantastic that you asked. We are indeed collecting all of the freely available open source apps that are built on the Fyne toolkit. We are always looking for new entries in here. It's a very varied list, as you can see if you visit this link. Let me just load that here. And so this is the current version of the Fyne apps site. There is a reference to that viewer that I was just showing you and to the OpenSnitch project. A couple of favorites that you will have seen earlier in this presentation. And there's a couple of other items that might look less familiar. This is a place to come and find the details of any of the projects that you're interested in. And it shows you screenshots, it gives you the appropriate information to download and try them yourself. Now, this list is definitely not complete, as we've been busy working on our release and also on pulling together this conference. It's got a little bit out of date. Applications are being written all the time, and we're excited to see what comes along next. If you know of an application that should be listed in here, you'd be very welcome to open a pull request on our apps.fyne.io repository in GitHub, where if the pull request is approved, it will appear directly on that site, and others will be able to find it too. Shortly, there will also be an integration for installing those applications much more easily than following links and executing commands yourself, and we'll be happy to share more about that later this year. So I hope that that presentation has really excited you about what's possible and what's easy with the Fyne toolkit, the variety of applications, games, and also just random projects that could have a new lease of life using the Fyne framework. So if you would like to know more and get involved, that would be completely amazing. We have lots of documentation available. Like I said earlier, it's really important to us that the documentation is readily available, easy to understand, and not just presented in the browser, but the IDE, as illustrated with the Hello World, is able to pick up this and make sensible suggestions as well. The first link on this slide shows documentation for developers. If you want to know more about the project or how it was designed or how you can use it out with the API documentation, that is a place to go. If you would like to actually make some contributions to the project, you should go to our GitHub account and find the Fyne project. Other projects are there, and you'll hear more about them later today, but for now you could go there. We have guidelines for contribution. It's where we manage all of our milestones and tickets. We have marked things that would be easy to start with if you're new, or areas of particular interest such as a Windows set of tickets, or if you're working on iOS, we have some highlighted that you could get involved in there. And as well as the Twitter handle and the live chat that we've had available today, there is always the Fyne channel on the Gophers Slack server. If you're not on there, then feel free to get an invite. It's in the footer of the Fyne.io pages. The Gophers Slack server is really for all sorts of chat about the Go language, and they are really a great community for asking questions or posing ideas. It's kindly sponsored by Google, I believe, so it's a full account with archives, so you can find lots of great information there. And in fact, we feel very lucky that Go as a language is so well supported. It's suited our needs from a programming point of view, but the community also is fantastic.